Hi everyone, Mrs. Vara here. This is the second video for section 12.5. This is where we take another look at the graphs to talk about holes. So holes are a type of discontinuity. Remember in section 12.2 we talked about asymptotes, and our graphs had this kind of shape, and we would have a vertical asymptote that it approached, and we would have horizontal asymptotes that it approached. So asymptotes are something that make a graph discontinuous. There is also another thing that makes it discontinuous, which is called a hole. And like it says, a hole in a graph looks like a hollow circle. It represents the fact that the function approaches the point but is not actually equal at that precise x location. So we always define where holes are based on their x value. So this graph right here has a hole at 2. When you graph them, that's what you'll graph. And so I'm not going to do this in this video, but I encourage you to, in your graphing calculator, or better yet, even in Desmos, it's a little bit more user-friendly, input this function, x squared times the quantity x minus 2 all over x minus 2. When you graph it, you'll get this shape graph. And then when you check table, either in your graphing calculator or on Desmos, so you'll have x's and y's, and you'll have, you know, the ones that match up with a parabola, just like your graph looks. You'll see these points, 1, 1, and then at 2, if you're in Desmos, it'll say undefined. On your graphing calculator, it'll say error. And that's because at x equals 2 over 2, you have a hole. Okay, now look at the function. If I gave you this function and I said, hey, simplify this function, you would say, oh, I have x minus 2 divided by x minus 2, those one out, and I'm left with x squared. And that's what your graph looks like. It is the graph of x squared, the parabola you're used to seeing. So this is exactly how you identify whether you have a hole or a vertical asymptote. If in your factored form, 2 factors, 1 out, that discontinuity is going to be a hole. It's still going to be a discontinuity because when you identify your excluded terms, you're going to say x cannot equal 2 because that would make the denominator 0. But then you're going to proceed to 1 out that factor in your denominator. So if you 1 out a factor, or 1 out a discontinuity, or 1 out an excluded term, that is a hole. Okay, so let's look at this problem. So the first thing we're going to do is factor this. So on the top, I'm going to get 4x minus 3 times x plus 1. X box on that, or skip x box. And then on the bottom, this is a binomial perfect squares. You're going to get x plus 1 times x minus 1. Okay, now, before we start simplifying, let's identify our excluded terms. So remember, that's take your factors on the bottom, set them equal to 0, solve. So what you would say here is, oh, x cannot equal 1, or x cannot equal negative 1. Remember, you can write that like this also, x cannot equal plus or minus 1. So those are your excluded terms. Alright, now let's simplify this. So if I simplify this, I'm going to say, oh, x plus 1 on the top, x plus 1 on the bottom, those 1 out. So now I know the factors that 1 out, x plus 1 is going to be my hole. So if I set that equal to 0 and solve, that means the hole is at x equals negative 1. So the factors that 1 out are your holes. So down here you would say my hole is at x equals negative 1. And this factor that didn't 1 out, that's going to be a vertical asymptote. So my vertical asymptote is at x equals 1. So check, also, put this in your graphing calculator, check this by graphing, and what you should see when you get to the table is you should have, for the y value, undefined at 1 and negative 1. And then when you look at the graph should show you the asymptote at x equals 1. Remember, well, maybe I didn't say this, The graph on your calculator or on Desmos is not going to show the hole. You're not going to see that hole. The table will tell you it's undefined there, and then you're going to sketch the hole. I think the next one we actually graph. So flip over to the back. If you factor this, you get f of x equals x minus 1 on the numerator. That can't be factored. X minus 1, x plus 3 on the denominator. So now let's figure out our excluded values. Those are going to be 1, and x cannot equal negative 3. So I know these excluded values are either going to be holes or asymptotes. Doesn't mean you're going to have one of each. You could have 2 asymptotes and no holes. There is no hard, fast rule here. I know something's happening at these. The way I figure out which is now I go back and simplify. X minus 1 divided by x minus 1, those 1 out. So I'm left with this. The ones that I 1'd out are going to become my hole. So now I know I have a hole at x equals 1. I still have a factor in the bottom. That's going to be my vertical asymptote. So this is going to be your VA. We're just looking at vertical asymptotes here. We might have a horizontal asymptote also. Alright, now if you do a table of values on this, put this in your calculator and graph it. You should get something like this. So negative 2 is 1, negative 1 is 0.5, 0 is 0.3, 1 is undefined, 2 is 0.2. And what else should be undefined? Negative 3. So I know I have a vertical asymptote at negative 3. I'm going to grab a pen here to graph that. So I'm going to go over to x equals negative 3. Sketch your vertical asymptote just like you did in 12.2. And now let's plot some points over negative 2, up 1, over negative 1, up a half, over 0. Okay, so this is got a horizontal asymptote at 0. And there we go. And, I should have been more careful here. I also need to put my hole in. I know when x equals 1, my function's undefined, so I'm going to put a hole right there. That's where my hole is. And then on this side, I have a couple more points that I didn't write down here. When x is negative 5, y is a half also. So 1, 2, 3, 4, 5. It's negative a half. Sorry about that. 1, 2, 3, 4, 5. Down a half. Negative 6 is negative 0.33, so over negative 6, down a little less. Negative 4 is negative 1, so 1, 2, 3, 4, down negative 1. So there's the other half. So this one, when you graph it, you can see your vertical asymptote. You are going to need to sketch your hole here, okay? Another way of finding your hole location is you know the hole happens at x equals 1. If you go to your simplified equation right here and you plug in x equals 1, you're going to get 1 over 1 plus 3, or 1/4. So then you know when x is 1, y is 1/4. And that's about where we showed it in our sketch. Okay, try this one. You're going to graph it and do this down here. I'm going to tell you to pause the video here and then come back and check it. Okay, what you should have found out here is the graph looks like a line. You have a hole at x equals 3, and you have no vertical asymptote. Okay, that is it.